Next panel approaching the stage here is Rethinking Materials, Embodied Carbon, and Beyond. This will be moderated by Gail Vittori. She's the co-director of the Center for Maximum Potential Building Systems and LEED certified. So thank you all for joining us here again this afternoon for UT Energy Week. And Gail, take us away.
Thank you so much, Carrie. It's such a pleasure to be here talking with this amazing group of people about embodied carbon and beyond, as the title is of this talk. Just a little bit about myself. As was said, I'm the co-director of the Center for Maximum Potential Building Systems based in Austin. It was founded in 1975. And we have, over the years, done a lot of work on materials. It was actually my first entree into my work at that organization back in 1979. It was an amazing opportunity to ask a lot of big questions about where do materials come from, how do they work, what do we know about them, and what do we not know about them. We have an open house, I'll just say, at the center every month, and if you're interested, I can chat with you about that later on today. I also serve on the advisory board of the UT Energy Institute, which is a sponsoring organization of this amazing Energy Week. And I also serve on the board of the Health Product Declaration Collaborative. So in addition to embodied carbon and a tremendous interest in that, I've also had a long-standing interest in how buildings affect us in terms of our health. And we will touch on that as we move through this session today. Also, I just want to prompt in terms of why do we think about this and what do we know about materials? I have 3 samples right here of different concrete materials. They look kind of the same, but actually they have very, very different footprints. Very, very different realities in terms of the embodied carbon in them. Very different footprints in terms of where the materials are sourced and how they're manufactured, how do they become these products. And so part of what we're learning with materials is that there's a lot of hidden and invisible information that there's now tremendous amount of work coming forward to make these properties much more visible and much more accessible, and to do it in a way that we actually will have confidence in them. So we're going to touch on all that today, but before we do that, I want to let each of our panelists introduce themselves, starting with Jen.
Okay. Hey y'all, I'm Jen Wong. I'm director of the Materials Lab right here at the UT School of Architecture. The Materials Lab houses one of UT's special collections. It's essentially a library of building materials. We have over 30,000 examples of building materials that are representative of products on the market today. One thing that distinguishes our collection from the rest of UT's special collections is that it's not really a precious collection. Any of the individual items in our library are all things that a design professional could request. Material samples are commonly used to coordinate material palettes for building projects. Often they're evaluated for their aesthetic or tactile qualities, so designers are really interested in color and texture and pattern and translucency, pliability of materials. But as Gail mentioned, there's a lot of information that is not visible that is in a lot of ways much more critical and important. And at the top of the list is definitely embodied carbon. There are a lot of other considerations, some of which I think we'll touch on today. Just to give you some examples of the types of things that we have in the library, we'll have full-scale examples of different unitized products like red clay brick or CMU concrete block. We'll also have swatches of things like upholstery fabrics or window coverings, different flooring types like cork and linoleum. So the one really great thing about our collection is that it's comprehensive and it's really representative of the current material landscape. Another thing that I do beyond curation of the material library is that I lead a team of students in educational programming, largely for the School of Architecture. So we organize things like workshops and exhibitions and talks on a lot of topics that tend to circle around or sometimes directly confront embodied carbon. A good example is actually an exhibition that I'll plug that opens today. It's called Looks Like But Isn't, and it's a co-curated with one of our faculty at the School of Architecture, Igor Siddiqui. We've assembled over 50 products that appear like their conventional counterparts, but have a very different backstory. So some examples are plant-based leathers made out of mycelium, made out of cactus, made out of different fruits, biomineralized concrete that's grown from bacteria rather than chemically produced from Portland cement. So those are some of the examples of things that are on display at our collection beyond just the kind of many, many conventional materials that are also out there.
And just to clarify, the exhibit is where on campus?
It's at the Materials Lab, which is actually only a few buildings down in the West Mall building, right along the West Mall. It's one of the 4 architecture buildings. It follows a lecture that's happening at the School of Architecture, and our reception is at 6 o'clock to 6:45 tonight.
Great, wonderful. Dirk?
Great. So thanks, Gail. Yeah, I'm Dirk Kestner. I'm the Director of Sustainable Design at Walter P. Moore. We're just under 1,000-person civil, structural, and enclosure engineering company. My background's in civil and structural engineering. For many years, I served as a structural engineer, project manager, et cetera. Though my educational background and my research at UT Austin was focused on recycling concrete, so kind of a structural materials focused master's, that 20 or so years ago when I came out of school, no one was paying attention to. They said, oh, steel's recycled, we don't really need to think about this as far as these materials. So it's been really interesting to see throughout the arc of my career how this has gone from something that was pretty basic, treated based on the dominance of energy consumption and emissions related to the operational phase of our built environment, and now that there's so much more awareness related to kind of the scope 3 or the supply chain side. And that's really driven a transition of my personal role within our company from one who was purely helping to deliver classic projects, perhaps with an environmental focus, to helping our teams across the country on their projects, as well as a lot of involvement right now with, I would say, everything that's going on from new materials to policy, to Gail alluded to the quantification and how we set this forward through frameworks, as well as whole building life cycle assessment and baselining and working to achieve optimizations and meaningful optimizations in the buildings that we're designing and what we're creating today.
Great, thanks. And Julie?
Thank you. Good afternoon, everybody. My name is Juliana Felkner. I'm an assistant professor in the School of Architecture, and I teach the structures and environmental controls courses, as well as sustainable design courses. Part of our research in the group is to look at ways to use less material through structural optimization, especially when looking at larger buildings. The structure is typically the most dominant form of carbon emissions in terms of the materials. And so how we can both optimize and reduce the use of the materials, but also help to inform the choice of what kinds of materials are out there. And so I help students to look at as well how the environmental controls are affected by those choices of materials. Everything from shading to thermal mass can lead to different performance levels. So I'm happy to be here today. Thank you.
Great. So this may be a new topic for Energy Week to be talking about materials, and why does it matter in the context of energy? As we know, the world is getting hotter. Last year was the hottest year on record, and we have signals from various bodies around the world to dramatically reduce our carbon emissions. The Paris Agreement calls for no more than a 2 degrees centigrade level of temperature rise above pre-industrial levels, and we are not on track. The estimates forecast global average temperature rise already of 2.5 to 2.9 degrees centigrade above pre-industrial temperature levels. And in the context of that, there's been a tremendous amount of work to figure out what are the big opportunities that we have collectively to start reversing that. And embodied carbon has arisen as one of those big opportunities that really until, I don't know, 10 or 15 years ago, no one was really talking about it at all. We were talking a lot about the energy performance of buildings, and that certainly is a big chunk, but embodied carbon is definitely an opportunity to start to reverse the trends in terms of emissions. How many of you are familiar with the term embodied carbon? Is this a new term or, all right, kind of some yes, some no. Is there a next slide up? Did we get? Maybe, maybe not. Oh, is there, I'm sorry. I didn't know whether, was there a clicker? All right, maybe there's not. Okay. So if there was a slide, it would describe graphically what embodied carbon is. And it's essentially, when you think about the process of sourcing materials, moving them from point of source to where they're manufactured, to actually the manufacturing process, moving them from that location to where they're going to be used. There's a lot of steps along the way that all are involving energy inputs. And then after the use phase, there's the post-use phase, which includes the demolition, the disposal, the recycling, the whatever might be called within the context of a circular economy. All of those also have energy inputs. And so we take out, in terms of buildings, the part about operating the buildings and just look at the parts that are about how this material came to be, everything that was inputted that had an energy component, and then after its use, everything involved that has an energy component that takes it to disposal or in a circular context back into a use phase again. So that's the embodied carbon. We know that overall, buildings represent 37 to 40% of global carbon emissions. In Austin, they're estimated to represent 50%, so actually more than the global average, what happens in our city here. And of that 37 to 40%, about 10% represents the embodied carbon of the materials that are used. And 28% of the global building-related emissions. So 10% of all of it and 28% of the building-related emissions. Interestingly, with all the good work going on to make buildings more energy efficient, the percentage of carbon related to buildings as a whole actually starts to lean more towards embodied carbon than operational carbon. And so that's a shift that's also causing more and more emphasis on how do we get as low a carbon intensity as we can for these materials. We also know that the national government is looking at this, global governments are looking at this, and just 2 days ago, there was, I think, a $6 billion investment in opportunities to decarbonize industries. And among those investments were those related to concrete and cement, aluminum, and steel and iron. So there's a lot of money going into this right now, and we think that there's a lot of promise. And with that, I'm going to start to pose a few questions and see if we can get some really great dialogue. So as I mentioned, the city of Austin has identified buildings as representing 50% of overall carbon profile. And the climate equity plan that was released in 2022, among other things, called for a 40% reduction of embodied carbon by 2040. So my question, the first question is, how do you think the city's best opportunities to be approaching that goal? What does that trajectory look like? What do we know and what do we don't know? And can you provide some examples of some projects, local or otherwise, that might be pointing the way? And Dirk, I'm going to start with you because I know you were involved in this issue in developing the City of Austin Climate Equity Plan.
Sure, I guess that that comes with having helped craft it. So maybe a bit of background on this because I think it's important to what we're looking at as we talk about this issue. One, this was the first time that materials really to this degree were included in the climate plan or the climate and equity plan as it was in that iteration. So there was a balance of making sure that we had a measurable goal, something to reach for, but also some level of uncertainty about what should this number be, what is meaningful, what gets us to a long-term trajectory that we want. So that 40% is measured from, when in the fine print, when you read the plan, from the 2020 business as usual in Austin. So that was crafted to make sure to say, all right, we want something that's regionally appropriate, that's meaningful to us, and then that does get us on that trajectory. Whether 40, 35, 50, I think 40 was a number that was agreed upon by committee. I kind of come back to this benchmarking piece because I think it's very important when we have these discussions and people talk about optimizations that a lot of numbers of percent reduction are thrown around without similar rigor to percent reduction from what. So that's that piece. The second piece is an acknowledgement that it will vary depending on material and industry, but there's some component of the emissions related to these materials will kind of ride along with changes that are being made irrespective of the building. And the example of that, I think, is the steel that goes in, the best example is the steel that goes into our buildings, because 99% plus of structural steel and rebar are all made through an electric arc furnace where the vast majority of the emissions come from the electron, producing the electrons that go into that process. So it's not primary steel. It's not, it's a different effect of the supply chain. So as the grid reduces its impact and the emissions associated per unit of energy, that material will have a larger reduction without impact. Now, concrete is kind of the flip of that, where those emissions are not just due to energy inputs, they are due to the chemical breakdown of making Portland cement. So that one, it's far less about the fuel. A component is due to combustion, but give or take half of that is just due to chemistry. So that's why these other binders are important. And then the third point when we're talking about this, kind of in the background of this, is that this also is not just 40% less impactful materials, but looking at the system of the buildings or the built environment. And that's important that we're looking at applying, life cycle assessment at the building level, or as referred to as whole building LCA, even though that whole is a little deceptive yet because we're not getting every assembly. We are working to get the data in, but that we're not looking at saying lower impact steel, lower impact concrete, lower impact glass. That's really easy. There are a number of forces that are kind of pushing the market to think that way, but that doesn't allow the system level thinking to say what is the way that we could most economically and efficiently get reductions, because it's not just going to be building the same way we built in 2020 with materials that are less impactful. It's also going to think about how when we include the impact of these materials, how does that change what systems we're thinking about? So as far as examples, I think that what we are seeing is the first step are some of these transitions. I think give or take half of the cement that's now used in the city of Austin based on our local suppliers is now, not to get too in the weeds, but it's a blended cement that uses a higher percentage of limestone, roughly achieves a 10% reduction, just functionally equivalent binder, but less impactful based on a bit of a new process, different specification. We're seeing even further changes, but that's kind of a tweak. We're also seeing a lot more transparency associated through what are called environmental product declarations, or the impact labels, if you will, developed through ISO standard processes, but so that specifiers, procurers, et cetera, can understand the impacts. So it's starting to move the ball along.
And moving decision makers into thinking that this is something that actually they can begin to integrate and incorporate. And I know, Juliana, you're involved in some projects as a consultant in addition to your work at UT on faculty. What are you seeing in terms of whether it's locally or more broadly, the uptake and interest in sort of setting goals to begin to hit some of these percentage targets?
Yeah, that's interesting. I think locally we have a good example. Datum Engineers is a structural engineering firm that's signed on to SC 2050, which is a goal to be net zero for structural engineers by 2050. And the way they're going about that, they're looking at optimization, but also different kinds of concrete they can use and different materials altogether. A lot of the limitations we're seeing is that it can be more expensive. The developers, as well as I think the contractors, need to be able to have a trust in the new materials, and if they're not experienced with using them, they may need some more information to understand them. So a lot of it is, market driven and also just education based, I think. In other countries, we're seeing it's required to report the LCA of the new buildings, and I think there are limits set on how much embodied carbon materials can have in countries like Denmark, Sweden, and Finland, as well as Norway. And they're starting by, I think, January actually of this year, they've started to count zero carbon for any material that's reused. So if you can reuse existing tiles from older buildings or any other components of a building, then that can effectively get them a zero rating for their embodied carbon for those materials. So to see materials reused in Austin from older buildings, I think would be really interesting to start to think what parts, even in building new buildings, how could these materials be reused?
Yeah, awesome. And it's also important to point out the climate equity plan includes equity, which is very intentionally ensuring that the benefits are equitably distributed. So this is, I think, one of the important contributions beyond just setting ambitious goals is to really embed the sense of equity as part of this broader initiative to transform the materials economy. Let's go to a next question.
Can I just jump on?
Sure,
in that? For me, there's two parts also to the question of embodied carbon in materials. There's, moving forward, what kind of lower carbon options can we select in the materials that we use? But then also, how do we kind of protect the embodied carbon in the materials that we already have present and in the buildings that we already have present? So I think that there are some really important basic strategies associated with each of those. I loved in Julie's intro talking about designing for lighter buildings or using less material. I think that's a great strategy, outside of just material selection. And then there's also a quote that has always stuck with me, what you build matters, but what you don't build matters more. So I think that's really important to consider as we, kind of come to potential end of lives for some of our building stock. Adaptive reuse is always a really great option over demolition and building new. There are other options as well, like design for disassembly, which on campus Irwin Center, that's a great example of a project where they're working to disassemble the building component by component as much as they can to reuse those materials rather than to send them to landfill.
Yeah, it has been fascinating to watch that happening so gradually, because usually when a building is coming down, it comes down overnight. So kudos to the team that sort of pulled together to go in that direction, for sure.
Yeah, and one thing, the UT's Green Fund was also involved in kind of giving the financial support to make that piece of the project happen.
Yeah. And also, just to say, embodied carbon is about how this is manufactured, but there's also an opportunity to balance it with sequestering materials. And so another facet of the work, the broader work in hitting carbon targets, is to see whether through trees or through soil or other landscape issues or wood use on projects that you can actually balance the emitters with the sequesterers. And that's a whole other sort of part of the calculation. So just in terms of how manufacturers are responding, we've touched on that a little bit, but Jen, you must have a great purview into that world when you're probably faced with the opportunity to bring a lot of new materials in and maybe get pitches from manufacturers that they want to have it in. What are you seeing in terms of the evolution of the kinds of products that are coming from manufacturers, and how much of them are now, in your mind, paying attention to issues like carbon and also, I'll say, ethical sourcing and healthy materials?
Yeah, I mean, I think that's a part of every manufacturer's story, whether it's the level of genuineness can vary, but I think every manufacturer kind of aspires to tell a green story and to address embodied carbon in some way. So a lot of themes that I see are manufacturers who are able to achieve their production using renewable energy, whether it's on-site or sometimes using carbon offsets to kind of balance out their manufacturing processes. A lot of manufacturers that are incorporating recycled content into their products. So, again, that idea of capturing existing embodied energy and kind of moving it forward. And there are a lot of ways that people kind of create circular products, whether it's incorporating post-industrial content, whether it's using post-industrial content. Sometimes it's created in-house using offcuts from different product lines, incorporating it into new product lines. Sometimes it's using post-consumer materials. So we have a great example. Everboard is a roof board created by a company in Houston, made from those really hard to recycle beverage containers, an alternative to gypsum board. There's also emerging manufacturers that were from conception have developed low carbon alternatives. So a lot of bio-based materials that are emerging, made from renewable sources, such as trees. So mass timber is a big thing in architecture right now. Obviously, lumber products are able to sequester carbon in buildings for the lifetime of the product, and hopefully it's something that will be able to be reused later on. Increasingly, there are also rapidly renewable products made from other bio-based sources like hemp or bamboo, agricultural byproducts, things like that. But in terms of scale, I really am excited about things like the Energy Department's announcement of the $6 billion in funding, because I think the big changes will really be made by those large-scale manufacturers of really major products like cement and paper and plastic. That just has a kind of scale of impact that goes
right.
far
And at the
beyond.
end of the day, scale is going to have to be part of the solution set, right? So moving beyond the prototype to actually scalable solutions that are going to be broadly accessible and change the standard specification for the building project, right? That starts to say it's going to have a low carbon cement that's going to be verifiable, and it's going to meet all the performance requirements, and it's going to be affordable, and it's going to be available in quantities needed. So all those things become considerations when you're trying to influence the bill of materials that are ultimately used in projects. And we have, I think right now in Austin, probably the biggest opportunity to make the biggest shift in terms of our material dependencies for buildings, because we have gigantic projects that are in the works now. We have the Austin Transit Partnership 9.5-mile light rail system that's being planned now to go through the city. We have the new medical center at UT, 2 gigantic hospital projects. We have the new convention center. And we have a major development at the airport as well. So it's not often that there's a convergence of such massive projects that are happening all at once. And so alignment, going back to the climate equity plan, all these projects have an opportunity to really reshape the way that materials are understood as having a role to play, not just to perform in the way we think about them typically, but also to be major contributors in reversing climate change and to set an example for others. So Dirk and Julie, on the manufacturers, like what are you saying? Dirk, you spec projects.
Sure. I mean, I'll be succinct. I think that the most important thing we're seeing is the approaching this in a quantitative way for whatever it is, because that both allows, it spurs competition, but also for the manufacturers, it allows them to understand their hotspots and understand kind of what the issues are, and moving beyond kind of the broader attribute-based to like measure it, understand your supply chain, because I think that everybody inevitably figures out something and then makes comparisons, whether it's requirements I might put in as a specification or whether 3 competing suppliers might be doing to get their number to be lower.
And Julie, you have a lot of experience in Europe. Just the contrast with the pace that is happening in Europe versus what you see happening domestically.
I think the regulations are tighter in Europe in terms of new materials and what they must declare in terms of, when looking at the environmental product declarations. It's also, they have more incentives. So I think you'll see embodied carbon in whole buildings is starting to be considered even from an investment point of view. So investors are starting to request this information if they have properties as part of their retirement portfolio. They want to know how much carbon is in that building, how much is it emitting, what is the risk it's going to become fined in the future. So in terms of individual products, I think there's also a lot of attention coming to human health and the excavation of the materials, the mining. I know in one case, I was working on a project looking at silicosis cases in Spain because the miners were getting very frequent lung conditions, silicosis, because of the particulates coming from mining and excavating the slate for the roof tiles. And so there's becoming more and more concern not only about the products once they're installed in someone's home, but also the conditions of the people who had to mine them and fabricate them from the beginning. And so you can see this with responsible sourcing certifications and understand, okay, was this sourced responsibly or not?
Well, that's a great segue to the next question, which is really about this convergence of carbon, health, and ethical sourcing. And this is, I think, an important threading of really significant issues as we talk about the transformation of the materials economy. Carbon has so much momentum with it right now, is that many of us see it as a way to bring in some of these other considerations that maybe are a little bit more nascent now. Not that they weren't already out there in the picture, but I think in terms of just momentum carbon's gotten, it's a way to say carbon plus healthful materials plus ethical sourcing. And ethical sourcing, just interestingly, there's a certification called Design for Freedom, which is starting to really bring much more attention to the kinds of concerns that Julie is mentioning. What are the exposures through the pathways that happen in the course of identifying the supply chain of materials that end up creating these products, including enslaved people, that globally is actually a very significant issue and concern. So a lot of issues to come up with, and just real quick, because we want to have some time for Q&A, just some general thoughts on that. I'll start with you, Jen.
Well, without much evidence, I actually think that human health is a great kind of entry point to getting people interested to these what I agree are very interconnected issues related to materials. I just think that, human health and people's individual health and the health of their loved ones is so much more immediate and accessible than sometimes we think of carbon as this kind of abstract, immovable issue to tackle. So I think that all of them are entry points, but I think that human health specifically is a great way to get people interested in, to increase their material literacy, to get them making better decisions, et cetera.
Yeah. Great, thank you. Julie?
Yeah, I agree, especially when you think about once the materials are installed in a building, it's very important to think about also the people installing the products. So I know in California they're starting to ban these composite countertops because the particulates that are involved in the sanding and
Like the manufactured stone.
The what?
The manufactured stone products.
Exactly, the
Right.
manufactured stone, exactly. So these can be very dangerous for the people who are having to work with them. But also it's important to realize when you hire a contractor, they may not be aware of all of the risks they're exposed to, especially when you think about asbestos for a typical home renovation project. A lot of our houses in Austin that were built before 1980 do have asbestos in the drywall. And so it's also important for homeowners to have that tested before they start to make holes in the walls and tear down cabinets or anything like that. Just knowing that materials can be very risky, even the microplastics and the finishings and the carpeting and the VOCs that people are inhaling, the asthma rates are skyrocketing in this country, and it kind of goes alongside all of our chemical use. So indoor air quality is becoming much more of a risk to children than outdoor even. So I think it's important to consider.
Asthma is the #1 reason why children go into the emergency room, and it is an epidemic now.
Yeah.
For some of the reasons of how materials are manufactured, the chemical ingredients in them, and yeah. Yeah, so
Absolutely.
certainly an important, very important consideration.
Yeah, and there's a social injustice that a lot of people who are living in homes that they rent, they don't have the means to change or modify their environment to make it safe, even to insulate it better or install higher efficiency windows. So yeah, there's definitely, that's impacting overheating issues as well, that we see that happening within Austin at a disproportionate rate for lower income levels.
Dirk, a few closing thoughts?
A lot of, well, I think we're kind of going from like, we started with multi-attribute and then we raised it to, you know, but I think that point of the complexity of its performance is a much broader definition than simply conforming to some ASTM or some spec. And it's a very rapidly evolving and changing time to think about the questions we're asking. I think that the key is to understand as many of these issues as we can and to understand the questions that we should be asking in the dialogue, because it is, there are inevitably trade-offs. And I think even, I know, Jen, you mentioned mass timber, and we talked about other impacts, and I think even just the baby step of this discussion, when we go from carbon to other measures of air and water pollution, like, yes, on a generic data set, the mass timber looks good. Even on that generic data set, the waters, or it is far less clear when we look at eutrophication, smog, et cetera, of how this looks. And that did not even touch the health or the existing buildings realm.
Yeah. So, you know, I think we're in an era where disclosure and transparency is becoming more of an expectation. And that is a good thing, because it's going to enable all of us to have a better ability to make informed decisions about the products that we build with. And with that, I'm going to close the panel, this part of it, and open up to Q&A. We have just 5 more minutes left. And thank you all for absolutely fantastic remarks.
Yeah, thank you.
Do you have time for one quick question if someone has one? One, maybe I'll be the host and ask a question. Then, if I'm building a building and I tell someone, yeah, I'd like it lower embodied carbon, can I get that solution? Does the contractor know how to do it, and the architect? How close are we to just someone being able to say, yeah, I can give you the lowest carbon one, or I can give you the lowest cost one, or maybe they're the same, but they know how to calculate it and they can give me a solution?
Yeah, I think that this gets to, I think, a great point of clarity of owner articulation goals. And I think that that point of expressing that embodied carbon is a measure that's of concern and that you would like options, I think is the best way to do it. But yes, you should be able to hire multiple contractors and design teams who can calculate this and who can give you a thoughtful response.
Any other quick question from anyone?
I'll ask.
Just repeat it.
Yeah.
In the UT specs, where would you see opportunity to reduce this?
So I think that I got a little bit of bias here with the materials I touch. I think that the way we specify concrete is the single biggest thing that can be done, because it is made mix by mix in a truck. You're not influencing a Nucor who's got one of 4 steel mills in the country. You're influencing what goes in the back of the truck for your project. And I think that succinctly going to performance-oriented specs based on the outcomes that you need, the performance is needed, minimizing or eliminating prescriptive requirements, and then making sure that the spec is open to both the, I would call them, ready in the truck binders and the emerging, the almost there, like next year binders. That's the short version, and happy to continue the discussion. But I think because the other piece that is missed sometimes is something as fundamental as having good quality control can allow you to better nail what you need rather than need to adjust for uncertainties through the construction process. And that can be efficiency, and that piece is missed sometimes.
And I think Julie's point before about the importance of having confidence, especially for structure, that these materials are going to perform, is valid. Of course, you want to have confidence in these materials, whether it's concrete or steel or mass timber. So the more we can be documenting our experiences and sharing information, the better, because that is going to create the ecosystem that is going to drive the transformation of the materials economy.
I just want to second Dirk's kind of steering us towards concrete. It's the second most used resource in the world after water, and there are several stackable technologies available to us today, right here in Austin, that could be implemented to reduce that footprint quite a bit.
Yeah, I mean, we talked about 10% of all of the global CO2 emissions being related to materials. 7% of that is cement. So that just is the magnitude of what it represents.
Okay, well, let's thank this panel, and I learned a lot about embodied carbon. Thank you very much.